Look at the surface of our planet. From freezing, jagged peaks that pierce the clouds, we plunge down into vast, endless flatlands and desert basins. These extreme contrasts are the active battleground of a geological war that has been raging for millions of years. What exactly are the invisible forces warping and carving the ground beneath our feet? And more importantly, how do the resulting shapes of the Earth dictate the rules for human survival? The first fighters in this war are internal or endogenic forces. Deep within the Earth, immense heat and pressure cause massive slabs of rock called tectonic plates to shift. When these plates smash together, the crust has nowhere to go but up. It buckles, folds, and pushes skyward to build massive, high-elevation peaks. The moment new land rises, the opposing external or exogenic forces immediately attack. Wind, flowing water, and grinding glacial ice act as agents of change. Through constant erosion, they physically shave down the rock, and through deposition, that broken rock is swept away to fill in and flatten the lower areas. Every environment on Earth is strictly dictated by which of these two forces is currently winning the battle, and where you live on that battlefield determines exactly what you have to do to stay alive. When tectonic collision wins, it builds massive fold mountains. The Himalayas define this process. Because the plates beneath them are still actively pushing against each other, these sharp, jagged peaks are incredibly young in geological terms, and they are still growing taller every year. The defining rule of life here is tied strictly to altitude. As elevation increases, the temperature rapidly drops. This strict climate gradient forces the vegetation to drastically transform. Thick coniferous forests at the base quickly thin out into hardy grasses, and finally surrender to bare, lifeless rock at the summit. Altitude is so powerful that it overrides latitude. Mount Kilimanjaro sits near the sweltering equator in Africa, surrounded by a warm, flat savanna. Yet, because it stands nearly 6,000 meters tall, the air at its peak is cold enough to maintain a freezing, solid ice cap year-round. Living at these heights is a constant physical strain. The oxygen is thin, the weather is brutally cold, and level farmland is virtually non-existent. To survive, humans physically re-engineer the slopes. Using a method called terrace farming, communities carve giant, precise steps directly into the mountainside. This creates small pockets of flat land to cultivate crops, while preventing the valuable soil from washing away down the steep grade. But the steepest slopes come with a heavy penalty. Gravity and extreme weather constantly threaten human settlements. Heavy rains and melting snow trigger rapid, devastating landslides and massive avalanches, capable of completely severing roads and erasing infrastructure in seconds. Surviving in the mountains is a relentless battle against gravity. Humans have to literally re-sculpt the solid rock just to secure basic food and safe passage. Moving away from the jagged peaks, we find plateaus. These are massive, elevated blocks of land with relatively flat table-like tops and steep drop-offs on their sides. They are born either from broad tectonic uplift pushing a massive area upward, or from ancient, thick layers of volcanic lava that cooled and solidified over millions of years. Because they sit high above sea level, plateaus are prime targets for external erosive forces. Over millions of years, rivers slice down through horizontal rock layers, carving out massive, spectacular valleys and deep canyons right through the flat tableland. When those rivers reach the steep, sharp edges of a plateau, they plummet. This creates massive waterfalls. Modern engineering exploits this violent drop and the immense volume of falling water, turning these natural cliffs into highly efficient sources of hydroelectric power. The true value of plateaus lies beneath the surface. Thanks to their ancient volcanic and tectonic origins, these massive blocks of rock are the Earth's global storehouses of minerals. This specific geology dictates exactly what humans do here. While the hard, rocky soil makes large-scale farming difficult, the rich subterranean deposits make intense, heavy mining the dominant economic driver for the people living on plateaus. They may not have the best soil, but plateaus are the industrial engines of the world, providing the raw mineral wealth and the massive hydroelectric energy that power modern civilization. If you follow the rock eroding off the mountains and plateaus all the way down, you reach the plains. These are vast, uninterrupted lowlands that rarely rise more than 200 meters above sea level. Plains are built by a mechanism called alluvium. Rivers act as massive natural conveyor belts. They carry eroded silt, sand, and clay down from the highlands. As the water hits flat ground and slows down, it deposits all that material, spreading it out to actively build thick, new, nutrient-rich land. This deep layer of alluvium is incredibly fertile, providing the primary canvas for agriculture. It is why regions like the Indo-Gangetic Plain can grow enormous quantities of rice and wheat, supporting the densest human populations on Earth. This fertility comes with a major risk. The exact same rivers that bring the life-giving soil constantly threaten to overflow. Seasonal flash floods can easily wipe out crops, homes, and vital infrastructure in a matter of hours. To conquer the flatlands, humans had to engineer massive, complex networks of irrigation canals and deep tube wells. This allows farmers to pull groundwater to the surface and predictably control the distribution of river water across thousands of miles of farmland. Plains function as humanity's global food bowls, but survival here depends entirely on our ability to master, contain, and properly distribute the flow of water. Finally, we have the deserts. While many assume these regions are defined simply by blistering heat, they are actually classified by one strict metric: extreme aridity, meaning a severe lack of precipitation. While the Sahara bakes near the equator, high-altitude regions like Ladakh in Asia are freezing cold deserts. The air is frigid, but because it holds almost no moisture, precipitation rarely falls. Humans initially survived here by clustering around rare water sources for oasis farming. Today, adaptation has scaled up. We now harvest the desert's two most abundant resources: immense open spatial footprints and intense unfiltered sunlight. By using massive solar arrays, we generate huge amounts of power from the empty space. Deserts are extreme tests of resource management. The absolute scarcity of water forces humans to engineer brilliant ways to unlock the immense solar and mineral wealth hidden in the dry extremes. Through sheer ingenuity, from carving stone terraces into the steepest mountainsides to routing river water across endless flatlands, humanity has figured out how to build civilizations on every single major landform. Humanity has grown so large and technologically advanced that our collective actions now function as a massive, destructive external force. The sheer density of human activity is taking a heavy toll. Unregulated mining is tearing apart the foundations of our plateaus. Aggressive over-tourism is destabilizing fragile mountain ecosystems. And heavy industrial pollution and raw waste are currently choking the vital river systems that run through the plains. Beneath the surface, the excessive extraction of groundwater to feed industrial agriculture is rapidly draining the aquifers. This is actively degrading the fertile soil of the plains and triggering severe, unnatural water shortages where water used to be abundant. Understanding physical geography now requires us to responsibly manage and protect the landscapes that sustain our future.